Yes, now we are discussing clustering method in machine learning. We already discussed about machine learning. Okay, we already discussed about the machine learning types. So we are discussing about the machine learning types. First one is supervised learning method, and second one is unsupervised learning method. So in the first division, supervised learning method. Supervised learning method having two classification. First two division. First one is classification. Second one is regression. Similarly, in the unsupervised learning method, we have to work with clustering and association also. Okay, so this is the clustering, and this is which is the basically a type of a unsupervised learning method. Okay. So an unsupervised learning method is a method in which we draw references from dataset consisting of input data without label responsive. That means there is no any label data. We just work with uh, between similarities of the data point. For example, we have a basket. In this basket, we have a potato, onion, tomato. Okay, and we just close. I said you close your eyes and just separate the tomato in single group and onion in second group and potato is another group. Can you separate this? Yes. How can we separate this? Just feel the structure of that particular data points. Just feel the structure of the potato, onion, and tomato. Okay. Make and assume some similarities between this particular tomato, potato, and onion. Okay. And we can separate different group. After complete back end of your vegetable basket, whenever empty your vegetable basket, you will open your eyes and you can see these three group. First one is potato, second one is onion, and third one is tomato. Tomato, onion, and potato. Okay, so I mean to say that there is no any labeling, there is no any training, there is no any idea about your target variable. Just we can create a cluster, create a group with the help of structure, with the help of some similarities of data points or any object. Okay, so similarly, we work with the unsupervised learning in the form of clustering. So generally, it is used as a process to find meaningful structure. I already said here, meaningful structure. Okay, explanatory underlying process. Okay, generative features. Okay, so we find out the structure and we find out some underlying explanatory underlying processes and just find out some generative features and grouping inherent in a set of samples. Okay, clustering is a task of dividing the population or data points into a number of groups. We can say we can say just grouping. Okay, if you have a more than number of peoples are there and just separate these number of people, okay, in a number of group on the basis of some uh, factor, okay, such that data points in a some same group are more similar to other data points in the same group, okay, and dissimilar to the data point in other group. Got it? So clustering is a task of dividing the population or data points in a number of group. That is most important thing. Okay, such that data point in a same group are more similar to other data point in same group. Okay, and dissimilar to the data point in another group. Okay, It is basically a collection of objects on the basis of similarities and dissimilarities between them. We try to make a group similar object in a single group. We try to object which is not similar with that existing group. We can make another group. Okay, so that would be we can say the collection of objects on the basis of similarities and dissimilarities. Got my point? Okay. For example, the data point in a graph, which is presented in next slide, this slide graph, the data point in a graph was clustered together can be classified into one single group. We can distinguish the clusters and we can identify that there are three clusters in below picture like this. We can see here in this picture there are three groups on the basis of similarities and dissimilarities. Okay, you can say this is the cluster where all of the data points having similar properties. Okay, this is the second cluster where all of the data points having same features, having same similarities. Okay, cluster number three, making of the group of that particular similar data points. Okay, you can say that number of cluster one, number of cluster cluster one. This is the cluster one having some data point, but these data point does not sim does not having similar properties with cluster number two. Got my point? So all of these cluster one, two, three, having some data points and a different similarities. Okay, these data points are not similar with this data point. This data point cannot similar with this data point. Oh, this cluster. These data points are not similar with this. Got it? All of these data point having similar properties. So we can make a cluster number one, and these data point having similar properties. That's why making cluster number two and cluster number three similarly. Okay. So clustering is very much important as it determines the intrinsic group among the unlabeled data presented. There are no criteria for good clustering. Depend on the cluster, depend on the user, what is the criteria that may use which satisfy their need. According to the user requirement, we can create the cluster. There is no any specific criteria to make a good cluster. Got my point? So it depend on the user, depend on all of us. What is the criteria you have to use which satisfy their need according to the requirement? We can do that. Okay. For example, if you want to search any movies on the Netflix, for example, uh, Animal, for example, Panchayat season 3. Okay. Recently, I watched that movie on the Netflix. For example, I will again open the Netflix after 2 days. So Netflix suggests to me related with these movies. So many movies to me related with the Panchayat season 3. Okay, so that is the similarity between the suggested movie and Panchayat season 3. Okay, it is not necessary for the cluster to be spherical. Okay, so this will be happen. There is not any spherical shape. It will be happen in this shape also. Okay, so clustering will be happen this way also. You can see the this picture. Okay, so I mean to say here, this is the example I'm taking to understand the according to the requirement of the customer, according to the requirement of the user, we can make a project, we can do the clustering. Okay. Second one is next is why clustering. Why? So there is some reason. First one is scalability. So what is scalability? Scalability in clustering implies that as we boost the amount of data object, okay, the time to perform clustering should approximately scale to the complexity order of the algorithm. Just boost up the amount of data object with the help of scalability. With the help of clustering, you can do that. For example, if we perform k-means clustering, we know it is a big O n complexity where n is the number of object in the data. If we raise the number of data object 10 folds, then the time taken to cluster them all should also approximately increase 10 times. Okay, so that is the scalability. It means there should be a linear relationship. If that is not the case, then there is some error with our implementation process. Okay, this is the example where scalability may lead to wrong result. So you can see before scalability, before scaling, you can see there are data instances. There are two features, height and width. Okay, and there are two cluster, one and two, and these are the data instances. But after scaling, you will get the result in this way. Okay, so this is the scalability. Second one is interpretability. The outcomes of clustering should be interpretable, easy to interpret that, and comprehensible, comprehensible and usable. Okay, so that is very simple to interpret and comprehensible and usable. Third one is discovery of cluster with attribute sets. The clustering algorithms should be able to find arbitrary shape cluster. They should not be limited to only distance measurement. They tend to discover a spherical cluster for small sizes. Next one is ability to deal with different type of attribute. Algorithms should be capable of being applied to any data, such as data based on interval or numeric, binary data, and categorical data. So, in the clustering, you can deal with the different type of attributes, which is based on anything, categorical, binary, and numeric. Okay, so there is no any specific requirement of that. Next one is ability to deal with noisy data. Wow. Database contain data that is noisy, missing, incorrect. Few algorithms are sensitive to such data and may result in poor quality cluster. Some of the algorithms cannot deal with this, but in the clustering, it is able to deal with this data, noisy, missing, and incorrect data. Next one is high dimensionality. The clustering tools should not only able to handle high dimensional data space, but also the low dimensional space. So this is the basic reasons for using the clustering. Okay. So remember all these things, why we use the clustering. There are some clustering methods, clustering ways. First one is partitioning method. There are some method we have to follow in the clustering. So first one is clustering method. Oh, sorry, partitioning method. It is used to make partitions on the data in order to form clusters. If n partitions are done on p objects of the database, and partitions are done on P object of the database, then each partition is represented by a cluster and should be less than P. Got it? So the two conditions which need to be satisfied with the partition clustering method, which are first one is objective should only belong to only one group. One objective should only belong to only one group. Second one is there should be no group without even a single purchase. There should be no group without even a single purchase. In the partitioning method, there is only one technique called iterative relocation, which means the objective will be moved from one group to another to improve the partitioning. So this is the basic thing which is happening in the partitioning method. Object can move from one group to another to improve the partitioning. Okay, so this is the partitioning method. Hierarchical clustering method. In this method, hierarchical decomposition of a given set of data object is created. Decomposition of given data sets has been done here. We can classify hierarchical method and will be able to know the purchase of classification on the basis of how the hierarchical decomposition is formed. We will discuss the hierarchical method in detail in the next slide. There are two types of approaches of the creation of the hierarchical decomposition. There are agglomerative approach and divisive approach. The agglomerative approach is also known as top-up, bottom-up approach. Initially, given data is divided into which object from the separated group. Given data is divided into which object from the separated group. Thereafter, it keeps on merging the object on groups that are close to one another, which means that they exhibit similar properties. This merging process continues until the termination condition holds. Divisive approach. The divisive approach is also known as the top-bottom approach. In this approach, we would start with the data object that are in the same cluster. Okay, that is the repetitive approach from agglomerative. Okay, the group of individual clusters divided into small cluster by continuous iteration. The iteration continues until the condition of termination is met and until each cluster contains one object. So that process will be continue until each cluster contains one object. Okay, so that is the divisive approach and that is the agglomerative approach. That is a part of the hierarchical clustering approach. In the divisive approach, clustering methods, in the divisive approach, once the group is split or merged, then it can be never to undone, as it is a rigid method and it's not so flexible. And one should carefully analyze the linkage of the object at every partitioning of the hierarchical clustering, and one can use a hierarchical agglomerative approach for the iteration of the hierarchical agglomeration. In this approach, first the objects are grouped into macro cluster after grouping data object into micro cluster. Micro clustering is performed on the micro cluster. Next one is density based method. The density based method mainly focuses on density. In this method, the given cluster will keep on growing continuously as long as the density in the neighborhood exceeds some threshold. In this method, the given cluster will continuously, keep on growing continuously as long as the density in the neighborhood exceeds some threshold for each data point within a given cluster. The radius of given cluster has to contain at least a minimum number of points. Grid-based method. In the grid-based method, a grid is formed using the object together. It means object space is quantized into finite number of cells that form the grid structure. Okay, the object space is quantized in the finite number of cells, small cells, like a grid. So that's why we can say here grid structure or grid-based method. One of the major advantage of grid-based method is fast processing time, because there are some cells are there, some grids are there where we can quantize your data data object. Okay, so we can say it's fast processing time. It is dependent only on the number of cells in each dimension in the quantized space. We already said model-based method. Next, in the model-based method, all the clusters are hypothesized in order to find the data which is best suited for the model. All clusters are hypothesized in order to find the data which is best suited for the model. So model-based. Okay, we have to find the data which is best suited for the model. Okay, the clustering of the density function is used to locate the cluster for given model. Density must be used there. Density function must be used there to locate the cluster for a given model. It reflects the spatial distribution of data points and also provide a way to automatically determine the number of clusters based on the standard statistics, taking outlier and noisy in the account. Constraint-based method. The constraint-based clustering method is performed by incorporation of application or user-oriented constraint. Incorporation of application and user-oriented constraint. A constraint refers to the user expectation or the properties of desired clustering results. A constraint refers to the user expectation or properties of desired clustering result. Constraint provides us with the interactive way of communication with the clustering process, and the user or the application requirement can specify constraint. So, application of clustering analysis. It is widely used in image processing, data analysis, and pattern recognition. Image processing, data analysis, and pattern recognition. It helps marketer to find the existing groups in their customer bases, and they can categorize their customer groups by using purchasing pattern. We already taken the example of the target marketing. Okay, here, for example, if you have an account in HDFC Bank or ICICI Bank, so you might be possible you received some call from that particular bank to opening the demat account or opening the credit card also. Okay, so how does it happen? This is the target marketing. There is use the clustering concept. Okay, to make some distinct group on the basis of customer database, and we receive the call from that particular bank. Okay, and image processing, we can say that whenever we work on the image like X-ray images, CT scan results, so then we have to use the clustering if you want to work on that image. Okay, pattern recognition. That means, for example, you have some data and you want to, uh, you don't have any idea what the target is, so you just create the pattern with the help of your raw data. Okay, with the help of some similarities and all. data analysis. So if you want to do some deal with, if you want to play some um, task with the data, like if you want to remove the noise or incorrect data from the data, so it must be uh, required the clustering concept. You must use, you can use. It can be used in the field of biology by deriving animal, deriving animal and plant taxonomies and identifying gene with the same capabilities. It also helps in information discovery by classifying document on the web. Information discovery. You just explore the information about any data on the web. Okay. So these are the basic application of the clustering. Advantage of the clustering analysis. It can help identifying patterns and relationship within the data, and that may not be immediately obvious. It can be used for exploratory data analysis, we already discussed, and can help with feature selection. There are, if you have a, for example, if you have a data with the 100 features, but there is some unnecessary features are also there. So you can just explore about the data and select some features to proceed to the implementation. It can be used to reduce the dimensionality of the data. If you want to reduce the number of features from, if you want to reduce the dimension, for example, high dimension to low dimension, in that case we can use also clustering. So this is the facility which is provided by the clustering. It can also be used for the anomaly detection and outlier identifications. Okay. It can be used for the market segmentation and customer profiling. So there are some disadvantages of the cluster analysis. It can be sensitive to the, there are some advantages, so must be there are some disadvantages of the clustering analysis. It can be sensitive to the choice of initial conditions and the number of clusters. It can be sensitive to presence of noise or outlier in the data. It can be difficult to interpret the result of analysis if the cluster are not well defined. Obviously, if cluster are not well defined, so obviously it is so difficult to interpret that result. It can be computationally expensive for large data set. You can deal with the large data set with the help of clustering approach, but it may be computationally expensive. The result of the analysis can be affected by the choice of clustering method used. It is important to note that the success of cluster analysis depends on the data. It is important to note that the success of cluster analysis depends on the data, the goal of the analysis, and ability of the analyst to interpret the result. Okay, so these are some advantages as well as disadvantages of the clustering method. Now we are discussing about the k-means approach. This is the most popular approach, clustering approach, k-means. This is the centroid based method. Firstly, we discussed about some points about the k-means. Then we have to take example to understand how it is work. Okay, so you can easy to understand. You can understand the clustering approach, how clustering method works. So k means it can be sensitive to choice of initial condition and number of clusters. It's depend on the user. It depend on all of us. What's your customer requirement? What's your choice? So you can given some initial condition and number of clusters are required. Okay, it can be sensitive to presence of noise and outlier in the data. Okay, it can be difficult to interpret the result of the analysis if customer is cluster are not well defined. It can be computationally expensive for large data set. The result of the analysis can be affected by the choice of clustering algorithm used. Okay, so let's take an example of the k-means. K-means clustering is an unsupervised interactive clustering techniques. It partitions the given data set into k predefined distinct cluster. You can value of k. You can assume the value of k as per the requirement. Cluster is defined as collection of data points exhibit certain similarities. Okay, it is basically it is based on the centroid method. Okay, so you can see this picture before clustering. For example, you have data points before clustering, before k-means approach, but after k-means you will get the three cluster on the basis of similarities of the data points. You will create the cluster. Okay, three cluster here after k means k. Here k is the three. K means it partitions the data set such that each data point belong to the cluster with the nearest mean. Each data point belong to the cluster with the nearest mean. Data points belong to one cluster have high degree of similarities. Data points which are in one cluster having high degree of similarities. Data points belonging to different cluster have high degree of dissimilarities. We already discussed about this is the centroid based method. First we have to calculate the center distance of all data points and we calculate the mean. Okay, we will discuss step by steps. And second one is the degree of similarities and degree of dissimilarities. Okay, these are some following steps we have to follow in the k-means clustering algorithm. Step number one. Firstly, we choose the number of cluster k. We choose the number of cluster, which means k. Step number two. Randomly select any k data points as cluster center. Randomly select any k data points as cluster center. There is no any specific criteria to select these data points as will be the center cluster center. You can randomly select first three. You can select, no issue. Okay, select cluster center in such a way that they are further as possible from each other. Step number three. Calculate the distance between each data points and each cluster center. The distance may be calculated either by using given distance function or by Euclidean distance formula. Step number four, assign each data point to some cluster and a data point is assigned to that cluster whose center is nearest to that data point. Step number five, recompute the center of newly formed cluster. And the center of cluster is computed by taking mean of all data points contained in that cluster. All these points we will implement in one of the examples, so it will be easy to understand what is going on here. Okay, so let's take an example to understand all these steps. Problems. What is the problem here? Cluster the following 8 points. There are 8 points: A1, A2, A3, A4, A5, A6, A7, A8. Okay, these are the points. Okay, which is representing the location, in x and y variable form. Okay, A having the location 2, 10. A2 is the point having the location 2, 5, A3, 8, 4, A4, 5, 8. Okay, X representing the A5 having the location 7, 5. That means 7 is representing by X, Y representing by Y. A6, 6, 4, A7, 1, 2, A8, 4, 9. Okay, so all these 8 point, and want to create the cluster. So here we want to make a 3 cluster. That means value of k is 3. Here value of k is 3. It's choice of user or customers. Initial cluster centers are, we already said in our step number 1. Firstly, we choose the number of cluster, and step number 2, randomly select k data points as cluster center. So we choose here initial cluster center A1, A4, A7. Randomly you can choose. There's no any specific criteria to select the A1, A4, A7, 3 cluster. Okay, just randomly you can select, no issue. So here we select A1, A4, A7. The distance function between two points, whenever you want to calculate the distance between 2 points, you have a formula. For example, here A is equals to x1 y1, b is equals to x2 y2. There are 2 points A and B. We want to calculate the distance, so you must use the formula p of a comma b is equals to mode of x2 minus x1 plus mode of y2 minus y1. Use k-mean algorithm to find the 3 cluster center after the second iteration. Okay, so let's restart the solution of that particular given problem. So iteration 1, we calculate the distance of each point from each of the center of 3 cluster. We calculate the distance of each point from each of the center of 3 cluster. We assume 3 cluster center A1, A4, A7. So now we calculate the distance by using given formula, distance formula. Here you can see here. Okay, so we calculate the each point distance from the all these 3 center. Okay, now following instruction shows the calculation of distance point A1 and each of the center of 3 clusters. So just taking a point here A1, having the location 2, 10. Okay, so firstly we calculate the distance between A1 and C1. C1 we assume here 210. Okay, we are taking all these 3 points from your given data as a center of the cluster. So we can assume center number 1 C1 and center number 2 C2 and center number 3 C3. Got it? Okay. Now we calculate the distance point 1 A1 to C1. So using here the formula to calculating the distance, P of A1 comma C2 C1 is equals to x2 minus x1 plus y2 minus y1, mode of y2 minus y1. Okay, put all these values and we'll get the result 0. Okay, because both are same. Now calculating distance between A1 to C2. Now we calculate the distance A1 to center number 2. Okay, so now we put all these value here, you will get the result 5. This is the distance formula A1 comma C2. That means you want to calculate distance A1 to C2. Mode of x2 minus x1 plus mode of y2 minus y1. Put all these value. This is the x1 y1. This is the x2 y2. Put all these value 5 minus 2 plus 8 minus 10. You will get the result 5. Okay. Similarly, we calculate the distance between A1 and C3. Okay. We already said we want to calculate the distance all each data point to all these 3 center cluster center. Okay, so that is why we calculate here x1 y1 210, x2 y2 12. Put all these value here, you will get the result 9. Got it? In the similar manner, we calculate the distance of all other points. We calculated here only one point to all these 3 center, but We want to calculate all these data points, the distance from all these data point to all three centers. Okay, so we calculate it. Next, we draw the table showing all these results. Using the table, we decide which point belongs to which cluster. Okay, with the help of minimum distance, we can calculate, we can identify the given point belongs to that cluster whose center is nearest to it. So now you can see here there are given points. We are having 8 points: A1, A2, A3, A4, A5, A6, A7, A8. Okay, so there are 3 centers. Distance from center to 10 of cluster 1. Okay, distance from 5, 8 of cluster 2. Distance from center 1, 2 of cluster 3. We all knows. Okay, there are 3 cluster we already selected and 3 center are already selected. So we already calculated for point 1 A1. Okay, distance we calculated from cluster 1 0, and distance calculated from center 2 5. Distance calculated from cluster center 3, we received 6. Oh, sorry, 9. So which one? All of these we are calculated distance from this point to this center, this point to this center, this point to this center. Which is minimum? Which distance minimum? So we can see here one of the point A1 having the distance, minimum distance from cluster 1 center, which is 0. That means that point, this point will consider this point will belonging to the cluster number 1. That is the reason we have to calculate the distance. On the basis of this minimum distance, we can identify the which point belonging to the which cluster. So we are having minimum distance here for the A1. So A1 having minimum distance from the center number 1 center. So we can see here this point belonging to the cluster C1. That means cluster number 1. Got it? Similarly, we have to calculate for A2. We have to calculate the distance from center number 1, cluster number 1, center distance from the center to 10 of cluster number 1. Similarly, calculate the distance. Similarly, we calculate the distance from center 5, 8 of cluster 2. Similarly, we calculate the distance from center 1, 2 of cluster number 3. Okay, after calculation of all these 3 centers distance from A2, we will get 5, 6 and 4. That means you can say A2 having the minimum distance from the cluster 3 center, which is 4. So you can say that A2 point belonging to the cluster number 3. That means it will be moved forward to C3. Similarly, we calculate for A3 distance from cluster 1, 12, distance from cluster 2, 7, distance from cluster 3, 9. So which is minimum? 7. That means you can say this data point belong to the cluster number 2. So you can say move forward to cluster number 2, this point. Okay. Similarly, we calculate for A2, A4. So from the cluster number 1, we have 5. Cluster number 2, we have 0. Cluster number 3, we have 10. Which is minimum? 2. That means you can say A4 having the minimum distance from center of the cluster number 2, 0. That means this point move forward to C2, cluster number 2, 5, A5. Having the distance 10 from cluster number 1, having the distance from cluster number 2, 5, having the distance from cluster number 3, center of the cluster number 3, 9. So which is minimum? C2. So that means you can say this point move forward to C2. Similarly, we calculate for 6, we receive 10, 5, 7, which is minimum? This one. So we can say this point belonging to the cluster number 2. Similarly, we calculate for A2. We receive the value, we receive the distance from cluster number 1, center 9, we receive the cluster number 2, 10, receive the cluster distance from the cluster number 3, 0. So we can say that which is minimum? Cluster number 3 distance, which is 0. We can say that A7 move forward to cluster number C3. Similarly, we calculate for A8 distance from cluster number 1, 3. Distance from cluster number 2, 2. Distance from cluster number 3, 10. Which is minimum 2. We can say that A8 move forward to cluster number 3. So this is the complete table which are indicating all given points distance from cluster number center of the cluster number 1 plus center of the cluster number 2 center of the cluster number 3, as well as we can see here all of these points are belonging to the which cluster. Okay, like A1 belonging to C1, A2 belonging to C3, A3 belonging to C2, A4 belonging to C2, A5 belonging to C2, A4 belonging to C2, A6 belonging to C2, A7 belonging to C3, A8 belonging to C2. Now, from here, new clusters are there. We can separate them. A1 first cluster contain point only one. You can see here. Is there another? No, only one point. A1. So from here, new clusters are there. A1 having only one, cluster number 1 having only one point, cluster number 2 having 5 points, 1, 2, 3, 4, and 5, and C3 cluster number 3, 1 and 2. You can see here. Okay. Now there are three clusters. Okay. Now if we recompute the new clusters and clusters, the new cluster center is computed by taking mean of all the point containing in that cluster. Okay. For cluster number 1, we have only one point, A1, 210 in cluster number 1. So cluster center remain the same. So cluster center remain the same because it's having only one point. Okay. How can we calculate the mean? Not possible. Okay. So cluster center remains same for cluster number 1. For cluster number 2, center of the cluster number 2, we calculate the mean. So just add all of these 8 plus 5 plus 7 plus 6 plus 4 upon 5. Similarly, this on this side 4 plus 8 plus 5 plus 8 plus 9 upon 5. We calculate here and divided by 5, we received 6 comma 6. This is the center of cluster number 2. Similarly, we find out the center of the cluster number 3. Okay, so cluster number 3 having 2 points, only 2, A2 and 7. So 2 plus 1 upon 2, 5 plus 2 upon 1 or 2. We will get 1.5 and 3.5. Okay, so cluster number 1 center is 210, cluster number 2 center is 66, cluster number 3 center is 1.5, 3.5. So this is the completion of the iteration number 1. Now iteration number 2. We calculate the distance of each point from each of the center of the 3 cluster. Okay, again that process will be repeat here. The distance is calculated by using the given distance formula. We already know that the distance formula. Okay, so the following station shows the calculation of distance from point A1 to 10 and each of the center of all these 3 clusters. Okay, so we already know the center, all 3 new centers, and we have any idea, we already have an idea about all these points. So just we calculate the distance from all these points to the new cluster center distance. Okay, so P of A1 C1, but all 210 new center 210. all these value put here and we'll get 0. Calculating distance between A1 and new C2, which is 6, 6. So put all these value and we'll get answer 8. Okay. And calculating distance between A1 and C3. Okay. Put all these value in the given formula, I will get 7. In the similar manner, we calculate the distance of other points from each of the center of 3 centers. Next, we draw a table showing all these results. Using that table, we decide which point belonging to which cluster as previous slide, as previous table. The given point belonging to that cluster whose center is nearest to it. Similarly. So again, we have all these all 8 points are here and distance from center to 10, cluster 1 center to 10, cluster 2 center 6, 6, cluster 3 center 1.5, 3.5. Similarly, we calculate the point number 1 to all cluster 1, cluster 2, cluster 3 centers distance using given formula. We already calculated in previous slide A1 C2 A1 C1 0, A1 C2 distance 8, A1 C3 distance 7, which is minimum 0. That means you can say here A1 belonging to the cluster number 1. So C1. Okay. Similarly, we calculate for A2 A1 A2 C1 5, A2 C2 5, A2 C3 2, which is minimum this one. So you can say A2 point belonging to the cluster number 3. Similarly, we calculate for A3 C1 12, A3 C2 4, A3 C3 7, which is minimum C2. You can say here A3 move forward to C2. Similarly, for A4, we calculate distance A4 C1, 5 A4 C2, 3 A4 C3, 8, which is minimum 3. You can say A4 move forward to C2. Okay, A5 C1 distance we calculate here A5 C1 10, A5 C2 2, A5 C3 7. So you can say which is minimum C2. A5 move forward to cluster number 2, A6 C1 10, A6 C2 2, A6 C3 5, which is minimum C2. Okay, so you can say A6 move forward to cluster number 2. Okay, similarly 7, we calculate the distance from all these cluster center. Cluster number 1, we have 9, A A7 C2 9, A7 C3 2, which is minimum 3. You can say A7 point belonging to the cluster number 3. Similarly, A8 C1 distance 3, A8 C2 5, A8 C3 8, which is minimum C1. You can say A8 point belonging to the cluster 1. Here we calculate all these point distance from cluster number 1 center, cluster number 2 center, cluster number 3 center, and we identify which point belonging to the which cluster. Okay, like A1 belonging to C1, A2 belonging to C3, A3 belonging to the cluster number 2, A4 belonging to the cluster number 2, A5 cluster number 2, A6 belonging to the cluster number 2, A7 cluster number belonging to cluster number 3, A8 belonging to the cluster number 3, C1. Okay, so from here, new cluster are here. You can see here cluster number 1, this one and this one, A1 and A8. Cluster number 2 having point A3, A4, A5 and A6. You can see here A3, A4, A5, A6. And cluster number 3 having the point A2 and A7. A2 and A7. Oh, so there are 3 cluster we make here. cluster number 1 having the points A1, A8, and cluster number 2, second cluster having point A3, A4, A5, and A6, third cluster having the points A2 and A7. Now we recalculate the new cluster centers. The new cluster center is computed by taking mean of all these points as we calculated in previous slide. So we calculate the cluster, new cluster 1 using the 2 plus 4 upon 2, 10 plus 9 upon 2. You will get 3 new center of cluster number 1, 3 comma 9.5. Similarly, we calculate for cluster number 2, 8 plus 5 plus 7 plus 6 upon 4. 4 plus 8 plus 5 plus 4. You will get 6.5, 5.25. You will get similarly for cluster number 3 center using 2 plus 1 upon 2, 5 plus 2 upon 2. You will get 1.5, 3.5. After second iteration, this is the completion of the second iteration. After second iteration, the center of all these clusters are C1 center 3, 9.5, C2 6.5, 5.25, C3 1.5, 3.5. All these three centers after iteration number 2. Again, we calculate if you want to calculate the distance all of given 8 point from these center, all these three new centers, and calculate this table, we find out same blogging class to the cluster. You will get the same result. You will get the same these result class cluster number 1 point, cluster number 2 points. You will get same these results. Okay. A will be having A1, A8, A2 or C2. Cluster number 2 having will be having A3, A4, A5, A6, and cluster 3 will be having A2 and A7 after new calculation. So this process will be stop here. Okay. So generally it will be same after completion of second number iteration. So this is your final cluster. Three clusters are there: C1, C2, C3. Okay.